Hi, Krista. Thanks so much for agreeing to interview with us today. So I first wanted to talk about some of the research that you did before you applied to graduate school. So could you talk about that and how you got involved in research?
Yeah, well, first I wanted to say thank you for having me today, Jackie. I've been really looking forward to chatting with you. Uh, to answer your question, I think I was a little bit intimidated at first to get involved in research. When I started undergrad, I was studying applied math and biology, and I kind of really focused on my coursework at first and didn't realize how valuable it would be to get research experience. I also think I was a bit intimidated by the idea of reaching out to a professor and asking them to mentor you, as well as I wasn't sure exactly what application of math and biology I was most interested in. But finally, I worked up the courage to reach out to Dr. Erin Bazadevan, who has a biomechanics lab that looks at uh, the way that your walking gait adapts because of different circumstances, such as stroke or walking on different materials, maybe walking on ice versus walking on sand. And that was a really, really awesome research experience to start off with. I learned the scientific process, and I also started to learn more about how to actually do data analyses on your own rather than just doing homework assignments with made up data sets. That being said, I think that by the time I graduated from undergrad, I realized that while I loved the lab I worked in, it wasn't necessarily the field I wanted to continue my studies. And I had taken a couple of computational and systems biology courses, so I thought it would be really exciting to try modeling on a more cellular and molecular level, and that's why I applied to be a research technician for a year after graduating.
Yeah, really interesting to hear how your interests changed over time and how you acted on that. So I personally am a huge fan of your work on the Morpheus paper with Professor Bree Aldridge, where you all use machine learning to identify the mechanism of action of antibiotics. So could you talk a little bit about this project and how you employed machine learning to solve that problem?
Yeah, I really love working on this project. It was my first time actually feeling like I had any ownership over the project, and I'd say at least for the computational aspect, I was the one that really got the pipeline going, and then a couple of wonderful technicians that followed me were able to finish some of the work. But uh, in in brief, Dr. Aldridge's lab studies Mycobacterium tuberculosis, which is a bacterium that causes TB. And what a lot of people don't realize about TB is that it's very difficult to treat. Currently, if you're infected with tuberculosis, you have a treatment of 4 drugs for a series of 6 months at least. And these drugs have a really harsh effect on the body outside of treating the disease. So it's an active area of research to identify new compounds that might be more potent against the bacterium. And the first step in this is identifying the mechanism of action or the target of some of these compounds on the bacteria. And a lot of people will do this by using high tech methods such as RNA sequencing to figure out on a genetic level what is happening, but this is really resource intensive. So what the Aldrich lab wanted to do was see if we can learn about what's happening inside the cell from outside the cell. And to do that, we performed fluorescent microscopy on drug treated cells and took measurements of things such as like cell length and width, as well as like how condensed the nucleus is, to see if we can find correlates of uh, drug treatment and drug target with these morphological or superficial features. And when we first did this, we tried applying a pipeline that already exists for other bacteria, such as E. coli. But the tuberculosis have such a heterogeneous response. We needed a more complex pipeline, and that's where Morpheus comes in. So Morpheus is this analysis pipeline that we created that stands for morphological evaluation and understanding of stress. And what first happens is you take all of the features you extracted from the images and perform feature reduction and also dimensionality reduction. So you're shrinking the space that you're working in, and then you perform k nearest neighbor clustering. And it's not until after this clustering that you start to see these neighborhoods of cells that were treated with similar drugs. And so you can do this on drugs that have known mechanisms of action to create a map of different drugs, and then you can input into the pipeline a new compound that you don't know how it acts. And you can gain insights about its mechanism by where it fits on that map of previously existing drugs. And then from there, you can create more focused hypotheses going forward that can be further experimented to validate.
Yeah, that's such a cool project, and it's so exciting that it works. It's awesome that your project as a technician worked. I feel like sometimes that doesn't happen like right away. But how did you make the decision to transition into graduate school?
Yeah, I was very lucky that my project as a technician worked. And as I kind of mentioned before, it wasn't finished when I first or finished working in Bree's lab. It finished a couple years later. But to answer the question about when I decided to apply to grad school, I think I knew that I wanted to apply to grad school before I even started as a technician. So during that first research experience in undergrad, I fell in love with the scientific method. The idea of coming up with some of the biggest challenges and unknowns and figuring out ways to investigate them and use data analysis to really to learn more about biology was exciting to me. So I didn't quite know going into being a research technician what I wanted to actually study and where my passions were. But that experience in the Aldridge lab really validated that I was interested in computational modeling on this more molecular and cellular level, as well as I gained this lifelong mentor in Dr. Aldridge, and she really helped me throughout the process of figuring out which grad programs fit my research interests and being a bit of a cheerleader throughout the process, which is a fairly stressful process.
Yeah, for sure. As someone that's gone through it, I can very much agree with that fact. But it's great to hear that you're still involved in the Aldridge Lab, and you feel that you've gained a lifelong mentor. That's an awesome feeling. So following on your scientific trajectory, you now work in Professor Doug Lauffenburger's lab, which is known for some really awesome computational modeling of biological systems and omics, multi-omics data analysis. And I'm really excited to see that you just had a couple of papers come out about COVID-19, given that, it's the pandemic. So if we didn't talk about it in the Zoom call, we would be remiss. But your paper on quick healers from COVID-19 used machine learning where it was a latent variable modeling approach to find some features that are associated with disease severity. So that's really cool. And I would love to hear more about it. So could you tell us more about that paper?
Yeah, this was a really exciting project for me because it was the first COVID-19 research that I worked on. And so it was about probably early May of 2020 when I joined this team that was starting to look into the antibody response to COVID. And this was when we really didn't know much, and people wanted to know if I get infected, will I have antibodies to prevent me from getting infected again? And to start investigating this, I joined this team of researchers led by Dwayne Weissman from Harvard Medical School, as well as Galit Alter from the Reagan Institute. And those two labs together produce a massive amount of data related to the antibody response. And when I say this, I mean there's different measurements of antibodies that are specific to the proteins on the outside of the SARS-CoV-2 viruses, as well as how well these antibodies produced by patients can bind to the receptors inside the human body that will elicit the immune response to protect you from the viral infection. And so we had this massive amount of data and had to start parsing through it to see what we were seeing. And one thing we noticed right away was that there was a very heterogeneous response in the sense that some people had high antibody titers, some people had low antibody titers, and it wasn't really clear what was driving this. So this is where my machine learning model came into play, because I wanted to know if severity of the disease tracked with a certain antibody profile. So I took all of this antibody data that they collected. I used ElasticNet feature selection to reduce to a smaller important feature set that was specific to disease severity, and then performed this latent variable analysis to see if we could classify uh, antibody features based on low or high severity. And the answer wasn't clear cut, actually. There was a trend that people with more severe disease had higher antibody titers, and that is almost to be expected, because if you have a really severe infection, your body's going to be working really hard to fight it off, and will produce lots and lots of these little fighters. And so uh, I was a little bit surprised that we were seeing that severity wasn't actually explaining all of the variation we saw. And later on in the study, we noticed that actually a better correlate of antibody duration was having a short infection, because the short infections were the ones that uh, had the most efficient immune response. And these efficient immune responses produced really robust antibodies that lasted really long.
Wow, that is so interesting. And it's awesome that you're doing this research to answer questions that, everyone's thinking about every day. And you also had another paper on SARS-CoV-2 transfer to the placenta during pregnancy. So just to zoom out, like from a personal perspective, what has it been like working on these COVID-related projects when all the world can talk about is COVID at the height of lockdown? Yeah, I mean, I'm sure it's been an experience.
Yeah, it's definitely been unlike anything that I've ever experienced before. So prior to the pandemic, I was working on HIV research, and in that sense, I was developing these machine learning pipelines, and my lab mates were, developing similar computational pipelines. And when this new virus emerged that no one knew anything about, we all kind of took these existing methods that we were working on and immediately started applying them to this new problem. And that's why you could see, both from my lab, but also from around the world, tons and tons of papers started coming out right away, because people were applying these technologies that they had already been working on. And we got a lot of information really quickly from this. And what I found most interesting, I think, from working on COVID research is how collaborative it is. It's hard to imagine a team being able to work so fast to churn out this research at the pace it's getting churned out. But I don't think that an individual alone would be able to do this. And when I first started back in the spring doing this research, my research team that I joined met every single day to talk about each person's progress from the last 24 hours. So it was definitely, it's been hard work, but you're very highly motivated by the fact that you see the translation of your research in the public health strategies that are being made, as well as, drug and vaccine development.
Wow, no days off for your group. That's so impressive. Looking forward to future pandemics and unfortunately other existing pandemics in this world that, in the US, we don't see the full impact of a lot of them. Where do you see machine learning and more broadly computational approaches coming in to combat these other future and current diseases that we grapple with?
Yeah, I think the work that's been done on this pandemic should serve as a prime example of the potential that machine learning has in really helping society with these both current and future pandemics. So, like I mentioned before, a lot of us are applying these machine learning and computational techniques that we had already developed, but there's also all these really innovative new methods that are being made. One of my favorites comes from MIT out of Brian Bryson and Bonnie Berger's lab, and they created this uh, pipeline using these existing natural language processing algorithms to actually identify viral mutations for SARS-CoV-2 that have the potential to evade the immune system. And this is such important information to get before it actually happens, and these viral variants are actually emerging in society, because maybe we can incorporate them in these vaccines that we're getting to prevent an even more dangerous situation. So I think in that sense, we can really have not only restorative measures from machine learning, but also preventative measures to prevent future pandemics from happening.
Yeah, I'm so glad you brought up that paper because I love it. And I also love highlighting other MIT scientists. All right, shifting away from research, I want to talk about something that you and I are both a part of. So we are both biological engineering data lab fellows, where we offer one-on-one peer coaching for computational help, troubleshooting, brainstorming, anything in the realm of computation applied to biology. So what has it been like? I know what it's been like for me, but I'm interested in hearing what it's been like for you in terms of coaching the newest generation of programmers and data scientists.
Yeah, so I think being a B data lab fellow is one of my favorite things that I do. I think that when I eventually retire one day, I hope that my contributions to science are not just like the research that I performed, but that I was able to help foster this new generation of scientists, and whether that be specifically data scientists or just biologists and other researchers who can use computational tools. And I think I get a good flavor of this from being a data lab fellow. Sometimes you start your appointments and the client is clearly overwhelmed with this problem that they have, and after a few like guiding questions, oftentimes they're able to kind of state themselves the process that they need to go through, and they realize that they actually knew all along kind of what they needed to do and just needed to talk it out and maybe get a little bit of advice here and there. And throughout the meeting, you start realizing that they have more confidence in themselves to really solve this problem, and that they had it all along. And I think this is really important because there seems to be this stigma against coding and math that, just a select few were born with a gift to do it. And, you know, oh, I was never good at math as a kid, so there's no way I can do it. And I don't believe that. I feel like if you have the right foundation and resources, anyone could use it. So I really hope that more and more people start using resources like the data lab, because I think computation could really uh, help a lot of people with their research questions.
Yeah, I couldn't agree with you more. Well, I wasn't expecting you to talk about retirement, but you did. So let's go back to the beginning of your career instead of the end of your career. And if you could go back and tell 18-year-old Krista anything, what advice would you give her?
Yeah, this is a tricky question. I still feel like I'm very early on in my career, but I'd have to say to 18-year-old Krista that she needs to stop worrying so much. But specifically, she should stop worrying about kind of the end goal. I think I've always spent a lot of time thinking about like, who am I going to be one day and what am I going to research? And I really, I've really been anxious that like I didn't know for a long time exactly what I wanted to do. But what I've realized more recently is that life is really a random walk. I wouldn't have ever known that there would be a COVID pandemic, and that I'd have this new research question that needed to be solved. I think what's more important is that you really focus on the here and now and like the opportunity that you have right in front of you and putting your all into it. And if you do that, you're going to get another opportunity. And at that point, you can decide, do I take this direction or do I continue on the path I'm already on? And then one day, again, when I'm at retirement, I will look back and notice that there was no predictive algorithm I could have ever made that would have guessed where I end up. So I think I'm continuing to give myself that advice sometimes because it's really easy to worry about kind of the unknown in the next step.
I love that modeling. Basically, a random walk down a decision tree is what life is. That's an awesome analogy. One more question to wrap things up. For younger students who are interested in data science and machine learning, is there any specific advice that you would give to students that want to get more involved in machine learning and artificial intelligence?
Yeah, so I think that as much as I love coding, being a computationalist can sometimes be a really isolating experience, but it doesn't need to be. And that's what's really important to remember. I think there's a difference, or at least I've always felt there's been a difference between, individually working on writing a script versus people who are doing more wet lab experiments that might be working together in the lab to perform something. And there seems to be more easy accessibility to having collaboration in that sense. But what I've learned more recently is that if you're intentional with, reaching out to other people and talking about your research with your colleagues, whether that be your lab mates or if you're working on a project, reaching out to your TA and professor, or, if you have resources like the data lab, because your project will never be at its fullest potential if you're the only mind that's going into it. Getting a diverse range of perspectives on your work is always going to, lead to new improvements. So I think what's most important that if you want to create your best product is to really join like the computational community and not go at it alone.
That's great advice, especially during this pandemic when it can be even more isolating for those of us that can work from home. Well, thank you so much for your time. This has been a really awesome interview. Yeah, thank you.
Thank you so much for having me, Jackie.